So homework for chapter 7, and each assignment is estimated to take about an hour or an hour and a half. Then today's goal is more examples for 7.2. And we're going to kind of change the overall schedule, and I'll send out an email soon with like actual dates. But right now we're going to wait to take exam 2. And this week is just doing notes. And we will not have an exam 3. Okay. Okay, so when is exam 2? Well, I was thinking to put it at the same time we would have taken exam 3, which let me peek at that date. And I'll try to make this decision tonight, or at least this week. Okay, so it would be so for week 12, it would be probably April, like the middle of April. So either Monday, April 12th or Monday, April 19th. I'll pick one of those days. Then you'll have time to take the test like before. Okay, so, and then this homework, oh, thank you. That's due Saturday, the 10th. Let's put here. Okay, and then the last thing to say is I know a few people have asked questions on WebAssign. I will respond to those soon. Again, getting back to doing everything today. So hopefully I'll have those let's see, questions answered tonight, examples today. All right. Okay, so the first one. And the integral of x minus 9. Okay, and yes, and again, I hope you had a good spring break, and we'll just kind of get back to what we were doing before break. One that's an indefinite integral and a definite integral, and hopefully that's good for today. Cool, so we need to divide by x plus 5 times x minus 2. Okay, so this section is partial fraction decomposition. So we'll do the partial fraction decomposition for, let's see, x minus 9 over x plus 5 times x minus 2. So we want this to look like some number a over x plus 5. Okay, plus b over x minus 2. And then we keep doing scratch work to find a and b. All right, so multiply both sides by x minus 5 times x minus 2 times x plus 5. Then x minus 9 equals times x minus 2. Add b times x plus. Okay. Here to here, we can use any value for x to find a or b. Like we could put in x equals 2, that will give us b. So again, you can pick any number for x, but a nice number would be 2. So 2 minus 9 equal to a times 0 plus b times 7. Negative 7 equal to 7b. I'm going to divide both sides by 7, and b will equal negative 1. I want to find a. So any number for x would work, but I could put in, let's try negative 5. So I'm going to give negative 5 a try. So negative 5 minus 9 is negative 14. Negative 5 minus 2 would be negative 7. We know b is negative 1. But we're going to have a 0 here anyway, so actually negative 1 times 0. Which is 0. Okay, divide both sides by negative 7, and a will equal 2. So I've got my integral rewritten. Well, we'll restate the problem and then change it to this partial fraction decomposition. We had integral of x minus 9 over x plus 5 times x minus 2. Okay, so the integral of 2 over x plus 5 and then it was a negative 1 for b, so we're going to subtract 1 over x plus x minus. Okay, so I will do the scratch work for each part, and then let's see. We're going to put the answer down and then do the scratch work. On the next problem, I'm going to have to make sure that we carefully do all of the scratch work together, because there's a little minus sign that I think is missing. Okay, so here's the answer to ln absolute value x plus 5. Subtract ln absolute value x minus 2. and then add C. Okay, so from here to here, we're going to show the work. Go up here, some stuff where we scratch. For this first part, we'll have 2 times the integral of 1 over x plus 5. And then dx, and just do this piece. Then we'll come back over here, take care of that part, and then just like as that kind of list of steps, add C at the end. Okay, so we have du dx. So derivative with respect to x equal to 1. All right, so du equals dx. Okay, so this will be the integral of 1 over u du. And that gives us 2 times ln absolute value of u, and then we'll put in u. Yeah, I'm gonna need space. Let's do this. So, okay, cool. To ln of x plus 5. Okay. That's part of the answer, actually. So remember, we're just doing scratch work right now. The other piece we need to talk about is the integral of, we're just going to, kind of have that subtraction sign sit there and take the integral of 1 over x minus 2 dx. So needs like some kind of substitution. Usually, you could do a u sub again, or you could pick another letter, like a w. Okay, so for this integral, we let w equal x minus 2. I have, well, let's keep doing scratch work. So take the derivative. Equals 1. dw, actually, split that. Okay, so here, we substitute w then this will give us ln absolute value of w. Plus c. So ln absolute value of x minus 2 plus c. That's that other part. I don't know if we did the plus c on the other integral, but actually kind of as like instructions I gave you was just to add c at the end. So, or if you want to put it right here, it could be some different number, maybe call it c1. So it's kind of different from that other value c, or just save that for like your last step. Okay, so we're going to try to do one that's a definite integral. Okay. All right, but before I do that, any questions or concerns? Okay, let's give this a try. Now, so I'm going to need help a little bit when we get to the scratch work part. Cool, that's better. That's cool and nice. And okay, number 2. We want to integrate from 4 to 5 C is a fraction with 1 over 9 minus x squared. And we'll factor the denominator. It's a difference of squares. And then we'll do scratch work for this part here. So we want scratch where some letter a, like some number, we'll call it a, over 3 minus x, plus some other number, we're going to call it b, over 3 plus x. And the goal is to have this equal 1 over 3 minus x, 3 plus x. And multiply both sides by the LCD. Go to 3 plus x times a added to b times 3 minus x will equal 1. And you can use any value for x, but I think a good number would be -3 and then +3. Let's try x equal to +3 first. All right. A times 6 plus b times 0. So that's gone. That's 0. 6a equal to 1 means a will equal 1/6. right, I think we were going to go with -3, but you know, any x is okay. All right, so that would be a times 0 plus, well, did I get this right? We put in 3 and we get out a. Yes. Let's put in -3. It should give us. Okay. For some reason, I was just thinking that we were missing something. But a times 0 plus b times. Oh, I think we have information instead of missing information. So I could put 1/6 here if I want to. Still 0 though. Okay, b times 3 minus -3 equal to 1. So again, that's 0. 6b equal to 1. So b is also equal to 1/6. So we're going to rewrite the problem that we started with and then put in a and b into those fractions, that partial fraction decomposition we had before. And then we also had bounds. So we're going from 4 to 5. 1 over 9 minus x squared dx. And we can write it as the integral from 4 to 5. Actually, 1/6 over both of those factors. So 1/6 over 3 minus x and 1/6. Okay, divided by 3 plus x, and there's a dx. Awesome. Let's factor out 1/6 and do more scratch work to actually get like the integral. 1/6 integral from 4 to 5. 1 over 3 minus x. Add 1 over 3 plus x dx. This is where I want to slow down a little bit and do scratch work. So let's start with this piece. And coffee. Okay. So again, we're going to go do work on the side and then come back and try to finish this problem, which I might just kind of have sit here for now. So let's back this part up. Space. Try to save this if I can remember to do so. Cool. And let's just do the indefinite part first. We'll come back and remember that they're integrating from 4 to 5. Integral of 1 over 3 minus x dx. Let u equal 3 minus x. Du dx. That's where it is. That's the negative sign. -1 on this side. So du is equal to negative dx. And let's come over here, write this as the integral of 1 over u times negative du. Oh, it looks weird. We need space. U was 3 minus x, so we're going to put that back in there and call that part good. Okay, so let's get at least this piece written. So we need a 1/6 times negative ln, absolute value, 3 minus x. Now let's go work over here and do scratch work. I'm going to pick a new letter. I like to pick W, but it can be any letter. Like, let's try T. So, explore scratch. Okay, this part we're going to have just an indefinite integral of 1 over 3 plus x. Let t equal x plus 3. Do the derivative, get dt dx equal to 1. So dt is equal to dx. And this is the integral of 1 over t dt. Ln absolute value t. Usually we'd add c, but this is just doing a little piece here on the side. So we don't need that right now. And we will put in t, it's x plus 3. So this is ln absolute value x plus. And then we're going from 4 to 5. So this problem we have, what are we going to call it? We're integrating from x equals 4 to x equals 5. Just going to finish this up here. Okay. I think we have everything ready to put in 5, and then we'll subtract, putting in 4, and simplify. Where are we on time? Good to go. Here, there. And we're going to put in 5. So let's do 1/6 multiplied by 5 for x. So negative ln absolute value of 3 minus 5. Add. Absolute value of 5 plus 3. subtract, putting in x equals 4. So we'll subtract a negative ln 3 minus 4. It looks really messy due to limited space on the whiteboard, but it's cool. We're putting in 4 right now, ln of 4 plus 3. So this is where we put in x equals 5, and then minus this part where we put in x equals 4. And then we'll work out all these absolute values and like some of these signs that are canceling out. 1/6 multiplied by negative ln, absolute value of negative 2. Add ln, absolute value of 8. So it's a minus minus, which means we're going to add ln, absolute value of negative 1. Then minus ln, absolute value of 7. All right, now we'll do the absolute values. Absolute value of negative 2 is 2. Absolute value of 8 is 8, and then this will be 1, and this stays 7. Negative ln of 2. Add ln of 8. Add ln of 1. And subtract ln of 7. Okay. This ln of 1 is going to be 0. And if you remember your log rules, which we'll write down after kind of putting this all together, we're going to have numbers that are, let's see, the logs that are being subtracted are going to have numbers that end up in the denominator. So ln of 2 down here. The ones that are being added end up in the numerator. And this is gone, and then this is going to have minus sign on the outside, makes it divide on the inside. Okay, so 1/6 ln of 4 over 7. Which I think, nope, I did not put it in a calculator, but that is the answer. And then going from here to here, just a reminder. Yep. Let's try this. Oh no. Okay. If you have ln of a times b, you can write it as ln of a plus ln of b. So that's where we had like ln of 8, say, I was going to multiply it by this, oh, let's see. So it is true that ln of 1 is 0, but I could have had this like ln of 8 plus ln of 1 equal to ln of 8 times 1. That could have worked out. And then there's the other rule that I used. And I'll call again after that also. You have ln of a divided by b. It would be ln of a and then subtract ln of b. So that's how I got this 2 in the denominator and that 7 from those minus signs. Okay, so those were the examples I had planned for today. And I think that's good for the rest of this section. So next time we're going to start 7.3. Okay.